Action!
Hi, everyone. I'm Beth Johnson, and with me, as always, is scientist Franck Marchis, and this is the Grudge Report, SETI Institute's science show following Star Trek Discovery's latest episode. Spoilers abound, so if you haven't watched the most recent episode, turn back while you still can. Hi, Franck. How you doing?
I'm good, and you? How are you, Beth?
Pretty good. I'm kind of surprised this year is almost over, and sort of happy this year is almost over.
It's like it's March forever right now.
Yeah, I think it's March 390 or 290 something.
Yeah. So that's good. We have shows like Discovery to make us travel through space and the universe. So.
And I understand you're very excited for the return of The Expanse.
Yes, you know that? You heard about this, apparently. Okay, we may have an Expanse Grudge report, so get ready.
Oh, right, yeah. I know a lot of you have been asking for one, so we have listened. I will not be on that, but Franck will be. We'll tell you more about that as soon as we have more info. All right, so this week's episode was Terra Firma Part 1, and I'll give my overall plot summation. One plot line was dealing with Georgiou's ongoing physical and somewhat mental breakdown, and finally finding out that the cause is the incredible divergence of our universe and the Terran universe, the mirror universe, over the past 500 years. And basically, because of the fact that she's jumped forward 900 years in time to a point where these two universes are so divergent, at her whole body is basically trying to pull her back, and it's pulling her apart. So she and Michael go off to try and fix this situation. And once again, the sphere has chimed in and has sent them off to a planet, and we'll get to that later. I was kind of surprised that the Admiral was just cool with it, but okay. And Book wants to work with the crew and be a part of things, and Saru kind of blows him off, which that's never going to end well. And that was kind of most of it. There's stuff going on with Adira and Stamets, and we'll get to some of that too. So
we're gonna go talk about this maybe signal as well that they decrypted. Okay.
Yeah, well, that and of course everything leads back to Georgiou at this point, and that's going to be interesting for next week. But let's get on with our science here. So, multiverse, mirror universes. What's that all about, Franck?
Yeah, this is not my field, and I frankly, it's for me border age science. So I'm just gonna go and say that directly to people. For me, this is really not science. It's a great concept, this idea of multiverse, but it's not something which has been proven, and it's not something we may be able to study, in fact. So just to remind people, because most of you know more about the multiverse than I know, the concept here is that there is a hypothetical group of multiple universes, and they are a universe is characterized by space, time, the constant, the energy, the information, the entropy, all of this. Okay, so there will be different type of universe which are copies, more or less, start with the same beginning, but may have diverged because they have different type of physical laws or constants. And in the show, we heard a bit more about those multiverse. We heard that we know about the Terran one, which was in the season 2, I think. But we also heard about the Kelvin universe, which is where this guy called Yor is coming from. And I did a bit of research, and apparently this is not the first time the Kelvin universe has been mentioned. Is that true?
That's true. So the J.J. Abrams movies are set in what has been referred to as the Kelvin timeline, and Discovery has taken that a step further and called it the Kelvin universe. So this was a neat little Easter egg to hand out to Star Trek fans, and sort of bring everything into one domain. So it's all interconnected, everybody.
Aye. So to go back to the science, a lot of scientists think like me that this is not a proven theory. It's a great concept to work with, but we don't really see any proof of existence of a multiverse.
It's hard to test for. It's hard to
Yeah.
disprove your hypothesis, really.
So in 2010, there was a paper. I will put the reference in the description of this video by Stephen Feeney. But basically, they analyze the background of the universe. Everybody have seen this. Is basically if you look at very low the signal coming at very low temperature around us, you will see the glare of the Big Bang drifting away from us at much lower temperature because the universe is cooling down. So this is called this was done by an experiment called WMAP, the Wilkinson Microwave Anisotropy Probe, and they have this beautiful picture. That was the first time we get a picture of this, the background, the fossil light of our Big Bang.
So this is the cosmic microwave background,
Yes.
correct?
Yeah. And
Right.
what they did, they studied the structure inside, and they claimed they could see an evidence of collision with another universe. So don't know the details much, but basically imagine you have two bubbles growing nearby each other. I'm doing a three-dimensional one because it's much easier for everybody here. And when they meet, there is basically this intersection, and you can see a variation, the borders of those two bubbles. And they claim they have discovered that in the background of our universe. Other observation taken later on with the Planck satellite, which is a satellite launched by ESA, to basically do the same, that WMAP, but a much better quality and much better sensitivity, revealed that there was none of this connection between universe in the background. Of course, this is something that we are still arguing about, probably. As I say, I'm not a cosmologist, so it's not really my field, and I kind of gladly know this. It's kind of sometimes, you cannot study everything, and there is stuff that you don't want to learn too much about. And when you hear people talking about it, you just leave the room slowly. That's what I do when I hear people talking about multiverse.
Oh, I'm not a cosmologist either. It doesn't really fascinate me. I'm a planetary scientist. I want tangible things that I can look at, put my hands on, and understand.
Yeah.
Cosmology, a lot of times for me, just feels like philosophical hand waving. Maybe this could be true. Okay.
So there is a scientist who basically said you cannot rule out. His name is Paul Stennart. I found that on Wikipedia, but I like this thing. He said you cannot rule out if a theory, if the theory provides for all possible outcomes, which is basically the case of multiverse. There is multiverse, then we cannot see anything in the universe. Interaction between those universes will produce some kind of phenomena. They can have universe with a different cosmological constant. Nothing is it can be proven because there is so many cases. Imagine if those multiverse are infinite, then there is no way we can basically prove their existence.
I mean, the entire comic book industry is basically built on the concept of multiverse.
Yeah. So I'm just gonna stop here. If you want to learn more, there is a ton of books about multiverses. It's great for the dinner conversation, but personally, in my case, I prefer to talk about asteroids, exoplanets, stars, and
I see moons. I'll take those. Yeah.
Exactly. Sorry if
okay, so so that covers kind of the wilder side of the science on this episode. But so the whole reason we've talked about this is, again, Giorgio is being pulled apart by the distance between the two universes, which, I mean, just think of them as galaxies moving away, but on a much bigger scale.
And in 4 dimensions.
And I know that one of the things that I've heard a lot about, and I don't know if this is the case with Star Trek, I couldn't find the answer to this, but I've heard a lot about, resonant frequencies, like that's how they detect when someone is from a different universe, because the frequencies that their molecules are resonating at is different. So,
which is not
okay,
something which has ever been proven, by the way, just so people know. We don't believe
right.
that. But because the cosmological constants are slightly different between those universes. The H value or the C value, those are the cosmological constant we use a lot. Speed of light, Planck constant. Maybe they may have a different vibration, yes, because of this. It's not completely
right.
out of the reality. It's possible. But then my question is, why when a body comes into the universe, the body still has the vibration of the universe where it's coming from. This is not really working.
Exactly. Okay, hand waving. Moving on. So to solve this problem, the sphere in Discovery decides to give them a suggestion. It analyzes all of the data, and it says there's a 5% chance that a solution can be found on a planet called Danis 5, which is on the edge of the Gamma Quadrant. So our galaxy in Star Trek is divided into quadrants. So if you look at it sort of looking down, think of it as a Cartesian map, basically. So tell us about Danis 5 and what you think of it.
I'm surprised you didn't mention is also near the galactic rim, which is basically
okay.
a limit of our galaxy. I still did not get that either, so maybe we can talk about that. But apparently there is a limit in our galaxy. If you cross the galactic rim, you're somewhere else and you lose your ability as a human being. But okay, let's go back to Danis 5. So Danis 5, well, it looks like Canada again, but in the winter time this time, right? So it's a planet which seems to be habitable. They breathe into it. There is no intelligent species on this planet. It seems to be a planet which has a lot of snow everywhere, and so a cooler temperature, probably close to the temperature we have in the winter on Earth. Something I notice in the show is that for a moment they're standing on the planet and you can see rings. So this is a terrestrial planet with rings.
Right.
Did not count them, and I counted there is like 10 of them. Something very surprising to me is that you can see the rings when you're on the planet, but when you see the planet from far away, you don't see the rings. I don't know if you see the picture, there is nowhere you see the rings in the show when the spacecraft arrive nearby the planet. And you do remember last week we criticized this already. We mentioned that there was supposed to be a moon or something.
Moon.
There was no moon.
Right.
And here they're supposed also to have a moon because they mentioned it, and we can see the rings. But when we observe from far away the planet, you don't see any of those. Right. I'm suspecting that the studio as being in charge of designing the planet is not the same that designed the background when they are on the planet. So they never really talk to each other, and the story of whether or not there will be a ring and a moon around those planets did not go through both studios. That's sad because it would be amazing to have a terrestrial planet with rings.
Yes, that would be really interesting.
We don't have any terrestrial planet with rings on our solar system. I'm gonna quiz you then. Let's do that, Beth.
Okay.
Terrestrial planet. Okay, let's talk about that. Mercury, right. Moon or ring?
Neither.
Venus?
Neither.
Mars?
2 moons, probably captured asteroids.
Exactly. And Earth?
1 moon, likely formed from a collision of a like-sized body and spit off, basically.
Exactly. So that's our solar system is very kind of boring. We don't have another planet like ours with a big moon, okay? And we don't have a planet like ours with rings. Rings, we see
Right.
them almost everywhere. There is rings around Uranus, Neptune, Jupiter, and Saturn. Everybody knows the
Right.
rings of Saturn because they're obvious. You take a tiny telescope, you can see them. But if you look at Uranus and Neptune, you see also rings if you use a good telescope.
Right.
So,
Actually, one of our colleagues discovered some of those rings, right?
yeah,
Mark Showalter was
not sure
responsible for
exactly
quite a few of those discoveries.
at the SETI Institute.
Yes.
So yeah, so Danius 5, what else can I say about it? Maybe we should talk about this alphaphantom.com. I don't know, the memory alphaphantom.com website. It's very interesting because you and me, every time we hear about a new planet in Star Trek, we Google the name and then we are sent to this website. And we always
Mostly to Memory Alpha, yeah.
yeah, and we're always amazed by the accuracy of the information provided into
The
this.
detail.
Yeah,
The detail. Whether or not it's accurate, that's I'm not 100% certain there, but it definitely is very detailed. I mean, the one for Danis 5, as you and I both commented, has the rotation period, the orbital period, the galactic coordinates, the gravity, the diameter. I mean, it had everything, and I don't think there was that much detailed information in the show. I
No,
think it was basically, look, it's a class M planet, it's uninhabited, here's rings and a moon, and that was it. So I'm always amazed. I mean, it even has the Memory Alpha entry even goes so far as to say it has an average temperature of 0.4 degrees Celsius. Yes, it's cold. Thank you. So
so we were
I love the article
wondering
writers here.
how people, where this information is coming from, and
Yeah,
I don't know. You
I
don't
don't
know.
know either.
So if you know, please let us know because I would love to hear where this information is coming from.
If you are someone who helps create the entries on Memory Alpha, we would love to know. Like, we would love to know how this whole process works because it's a great wealth of knowledge, and I use it to look up details that I have long since forgotten and try and find new stuff to talk about. So I'm very interested in how this one works.
And is this peer reviewed? Meaning that, imagine, I'm gonna give you an example. We both watching the show, and we decided that we're gonna write an intro for Danius 5. So we go on this website and we start writing it, and you come 5 minutes later, and you realize that you disagree with those values. So how this community, how this, what happened in this case? Who is the author of this? Is it only the first person that entrance which are taken into account, or there is an average, or there is a discussion in the background? Is
Well,
there?
I think it works. I know it works a lot like the way that these wikis work a lot like Wikipedia does. So there are people who sign up to be contributors, and that you can look through the revisions, and I think there are ways to have conversations in the background and discuss these things. So I think it works similarly, but I'm just not sure what what makes someone write the details in this fashion. Are they using some sort of logic? Are they just making it up off the cuff? Where are they getting the information from? I'm really curious. I really want to know.
All right, so
I
let us
I
know.
don't want to I don't want to correct it. I don't want to argue with it. I just want to know. Like, I'm fascinated. As Spock would say, fascinating. But I want to know the logic. All right. So we've beaten that horse enough. Um so they go to Danis 5. It's brutally cold. And the whole thing is that Giorgio has to make a choice to step through a portal, and she makes the decision, and she's transported back to the mirror universe, but she's in her past, and she has to figure out when she is in her past. And I don't really want to get into all of that because that's heavy plot and not necessarily heavy science.
Exactly.
It's really interesting, and it's definitely going to bleed over into next week because next week's trailer was entirely mirror universe. So I guess we have to resolve this. But there was a couple other plot points in this episode that we kind of need to take a look at. So Stamets and Adira have been trying to solve the message of the emergency transmission that came from the Virubin Nebula, which we talked about last week. It turns out to be someone who's Kelpian, and the message cuts off, and I know this is going to lead to more further adventures and shenanigans, and Saru's going to have to deal with it. But I wish we'd gotten a little bit more into it this week, but it really did just kind of go, okay, and now we're in the mirror universe and nothing else is going on. So let's talk about that one last issue in the mirror universe.
I thought you mentioned this about the Stamets. You remember yesterday we discussed the Saru moment?
Yes.
But in fact, there is another Saru moment in this show. Stamets comes, enter, and Adira is exhausted. Right. He has been trying desperately to make something work and run different algorithm, blah, blah, blah. And
it's stuck, it won't keep going, and yeah.
So
did you restart?
Yeah, exactly. That was kind of that was a Saru moment again. That was like something obvious that she forgot, and that's something you always need in your life. That's why science always works with a group of people. In fact,
right. You can't do science in a vacuum. You have to do it with other people involved. Otherwise, you don't see everything. It always helps to have that fresh perspective.
Okay, right. So the Terran. Well, let's go back to the Terran universe, because you and me, when we hear that, we basically jump onto our computers and start talking about it. So,
right, absolutely. We both took notes and then we both looked this up. So there's a moment where Georgiou is back in her Terran Emperor, her Empress mode, and she's trying to stop Michael from trying to overthrow her, because that's what leads her to killing Michael. Anyway, we're starting to see this softer side of this particular Georgiou, and she's having a rough time with it. But Michael sits down, Mirror Michael sits down and reports to her on about a planet called Kepler 174d. And of course, as soon as I heard Kepler, I went, wait, that's an actual planet. So what did you find out when you looked that up that made you kind of look twice at this episode?
So first, I would just say that what surprised me the most is the fact that in this parallel universe, they had a Kepler mission. Okay? So that's the most important part here. It's like if Kepler had to happen no matter what, in our universe or in parallel universe. So Kepler, for those who don't know, is a space mission, is the name of a scientist, but it's also a space mission that was launched in 2009, roughly. Which basically look at the same area of the sky to detect exoplanet by transit method. So,
right. So we watch a planet basically pass in front of a star. The star's light dims, and we can use that dimming along with the size of the star to measure things about the planet and to detect the planet, to know that it's actually there.
So when the spacecraft detected something, the object become what we call a Kepler object of interest, a KOI. And when the object is confirmed through with another instrument, it becomes Kepler dash and a number. And if there is multiple system in multiple planets in the system, then the planets are called B, C, D. So this is Kepler 174d. It's a planet in orbit around I forgot the type of the star. I look at it and I forgot. But it's the star which is far away from us. We're talking about 1,100 light years away from us, something like this. The planet, we have the characteristics of the planet, which are typically the orbit. So we know the period of rotation. In this case, is not something we made up by writing quickly on the wiki page, but something we calculated. So it's 247 days. So it's kind of far away from its star. It's a planet which is no eccentricity, a bit like Earth, but it's not an Earth-like exoplanet. It's a Neptune-like exoplanet. It has a mass which is 5 times the mass of Earth. and a radius which is twice the radius of Earth. So we think it's a Neptune light. But once again, and Beth, you're gonna explain that better than me probably, it's not, we have not seen this planet. We have seen the shadow of the planet.
Right. And so this planet it's around a K-type star. So
K-type.
and it's about 1,300 light years from Earth. So it's very distant. And all we have basically are the stats from it. So we've seen it pass in front of its star a few times, gives us enough to say, okay, if it's a K-type star and it's about this big, it's this far away, then this planet stops blocks the light for this long, it must be about this big. And that's how we get to, it's about 2.19 times the radius of Earth. So then you can kind of do some math from that, figure out what the mass approximately is. And basically what they determine is that it's Neptune-like. So Neptune-like does not imply having a surface that you can actually walk on.
Yeah.
And yet Michael is saying that there's an artist colony that's at this planet, and that, we won't go into the gruesome details of what Michael does, but my question was, how are you doing that on a Neptune-like planet? And of course you offered the solution,
which is that they mentioned the planet, but the civilization is not on the planet. It's on the moon of the planet.
Right.
And there's two reasons for which I think this is the case. Is first, the planet is far away, is not in the habitable zone. So this species is basically should be capable of living in a very cold environment. But if you live on the moon, right, you can maybe use the energy coming from the moon, like we have for Io or Europa, due to the gravitational interaction between the planet and the other moons, to live there, to create a society. So it's a planet. I'm totally making this up right now while I'm talking to you, so that's frightening. But here's my idea. It's a planet, Neptune-like, with plenty of moons, maybe Lilian satellites-like, and they orbit around the planet, but they have slightly eccentric orbit, so that squeeze slightly the planet, like we see for Europa or Io.
And we've got there's enough moons that I'm sure there's some resonance in there. So you've got moons one's going around 4 times for every 2 of another, and so they're pulling by the planet and by the other moons, and you get that wonderful.
There is kind of volcanic activity or thermal activity like we have in Iceland, and this civilization is basically a civilization that grew by harvesting the energy of this volcanic activity, and that's the way we have liquid water as well.
Right. So we're going to go with that. Problem solved. we could now write a memory alpha entry on that.
Okay, let's do that. There is memory alpha entry for this one, but it's very short. So I think we should really ask if we could make it better. Aye.
All right. That's our next task, everybody. Okay. All right, Franck, any closing thoughts on this episode?
No, I look forward to watch the next one. It's gonna be interesting. As I say, I'm not very fascinated by the multiverse world, and I don't really like the Terran universe either. Like this kind of semi-Nazi thing.
Not very likable.
No, probably not my kind. But it's good that show the contrast. It's good sometimes to show those bad people, so you remember how happy you are living in the Federation. So that's exactly what I like in the show. Okay.
Well, and if it gives us some character growth for Giorgio, then great. I mean, I like her the way she is, but we'll see how this turns out. All right, everybody. So that's it. We'll be back next week, which in this case is in about 3 days. Don't forget to subscribe, ring the bell for notifications, leave us comments. Please make them nice ones at least. And feel free to ask questions or comment on the science, or even comment on the plots of the show and how you disagree with it. And we'll be back in a couple days. So thanks for watching, everybody. Live long and prosper.